Okay, guys, online, shall we please resume? Okay, let me just quickly import this file. Read.csv. Simple function I'll be using. Okay, header, it has a header, therefore I'm saying header. Okay, header equals true. Let me look at this of the data set. Let me please look at the structure of the data set. Can you see the structure? Can you all see the structure, everybody? Let's see here, there are 400 observations. I think it should converge. It should not, it's not a massive data set. We should fail to converge. I expect it to converge. There are 4 columns, the good thing, correct? 4 columns. I think it should not struggle to learn the weights and such things. Sure, right? Next, guys, what I'll be doing is what is called as, once you import the data set, there is certain pre-processing that you have to do to the data set, right? Okay. We have to do certain pre-processing. One of the pre-processing steps that I'll be doing is normalization, right? Any idea why do we use normalization, guys? What is the idea behind using normalization, please? To get all the features. Okay, when do I use? Okay, good answer. One is normalization. The second one is called as standardization. When do I standardize? When do I normalize? I don't know if people online are able to hear me properly. Just ask.
Yes, we can hear.
Standardization that when I look at this different upper cap and the lower cap for different variables, and we try to find out the actual threshold of it, and then try to standardize it. As normalization try to involve particular range.
Within a particular range. Okay, when do I use what? Like for which algorithm do I use what? Why not standardization here? Why normalization here? Normalization will not necessarily bring it under the bell.
Standardization is bring it under the bell curve. Change the standardization.
Okay.
Normalization, it's like, okay, what is the range that we want to normalize with a certain range in max to bring it under the limits.
Okay. Yes. Okay, positive range is what we'll have. Okay. Any reason you think positive is easy to do? Okay, a couple of things here, guys. Okay, just a couple of things here. One is what is called as standardization. Second one is called as normalization. Both of these techniques can be used for pre-processing and standardization. Standardization. What are you doing with standardization? You are subtracting the mean from each value and dividing by the standard deviation. In Python, you have a standard scalar function. That is what you'll apply. Right? When you do a standardization, after standardization, there is no range I can specify because it can be -1, -2, -3, it can be anything, correct? And the second one, when you talk about normalization, what you're doing is from each value, you're subtracting the minimum, dividing it by the range of the entire thumb. Correct? Now, with normalization, the minimum will always lie between 0 and 1. Okay? As a thumb rule, there is no, nobody can suggest saying that this technique use this particular pre-processing technique. But as a thumb rule, any statistical technique that you use, under the sun, you can use standardization as a data pre-processing technique. But for any machine learning technique, by and large, we use normalization as a technique before data pre-processing. Right? In the case of standardization, we assume that the data follows normality. So for example, if you're working on a linear regression or principal component analysis and such things, it's always advisable that you standardize the data. Right? On the other hand, if you're using other techniques like your neural network or for, let's say, a deep neural network and such things, we use normalization. Is this part clear, guys? Clear, right? So let's do a min-max normalization of the independent variables here. Correct? I've got three variables here. What I'm doing is from each of the variables, I'm subtracting the minimum value from each of the independent variable. I can't do this trick with a dependent variable because dependent is binary here. Dependent is binary, so I'm subtracting the minimum, dividing it by the range. Right? And once I do this, I will be sort of saving the object as GRE itself, which will basically overwrite the original data set. Yes, please. Following? Yes, first it, right? Just subtracting the min, divide by the range, store it, overwrite it as GRE. Next is basically same thing I'm doing with GPA. Right, you can just copy paste the code, just change the variable names.
Yeah, but the first one is supposed to.
Yeah, that there is no shortcut. Right? GRE, GPA, and I'm doing the same thing for rank as well. Dependent variable, you don't need to do this. Done. Okay. Okay, let's just even before I proceed to the next stage, what we can do is we can just quickly do a structure once again of data. Structure is not there. How can it not be? Okay, you can see here, most of these guys are lying between 0 and 1. After normalization, you can see here, you can just see the values are lying between 0 and 1, right? If you want, you can just run a summary function on the data as well. You can see here the minimum value is 0, maximum is 1. So normalization will ensure that all of these values are between 0 and 1. So far it's clear. Input scaling we have taken care of. Now let us just quickly move on to data partition. I'll be setting the seed. This will ensure repeatability. Right? You all are clear with the splitting the data, right? Train, test, right? Why do we split the data? Why so?
The model should not see the train from the training in the train data and test it using the test data which is not seen by the model.
Basically, you can see the, you can assess the performance of the model, only the test data, not the training. Right? And it also prevents overfitting of the model. It prevents overfitting. You can just basically check the overfitting part of it at a later stage. Okay, what am I doing here? I'm going to create two different samples, guys. Right? I'm going to create two different samples. 70% will be assigned for training and the balance 30% will be assigned for testing. Set.seed of 2 to 2. Right? Then you use the sample function. Right? You need two samples, n row of data. Based on row is your particular sample. Replace is equal to true, which means that you're willing to replace the unit back. And probability is 70% will go under training, 30% will be under testing. All not clear? Right? Okay, so far clear? Yes, Raghu. Okay, okay. In the end, HTML code, something. I have seen that. You're right. I'm just pulling your link. Okay, guys, let's carry on. I have just basically sort of created two samples. Now, what we will be doing is we can assign int equals 1 as training. Okay, so this is the training data set. Okay, similarly, let me go ahead and create the test data set. Go ahead and create the testing data set. Ravi, it's all. Sir, here you have two brackets. It's ending with two brackets. Okay. Okay, guys, in case you have not installed the neural network package, please type install.py packages within bracket double quote neural network. Have you done? Working? Working. Working.
Sorry.
As you said, it's that.
Bharat.
Install these packages. Then in R, basically, once you install the package, next one is to basically call the library. Call the library. Earlier, we set the seed for the sampling part. Now, this is the seed for modeling part. Network also, which records will be used. That is another.
But already seed is set, right?
That is for training and test. But once training, fine, 70% of the records will be going into training. Now within neural network, we will change it and we will build multiple neural network models.
So within each library, we need to call the seeds.
The second one.
I didn't understand why you're setting C.
That seed was for training and testing. You'll fix the seed, 70% will go to training and 30% will go to test. Correct? Now that training data set will be pushed into the neural network. Neural network, when it is learning, it will give you one set of solution. Correct? We can build multiple neural networks. 5 different neural network models we can build. When I say 5 different neural networks, again for the model, it will be choosing a different set for building each of the models. So that's the reason why another layer of C we are shipping. This is for for the model selection.
But we can use the same seed, right?
You can use. Yeah, 2 like that you're saying, is it? I use the same.
Then in Python, we are setting the seed only one.
Random underscore state equals 1.
No, but we are not setting.
You're building one model there. Here I'll be showing you within the, you can change the algorithm and get 5 different neural network models. 5 different, it's like building, just as you built logistic regression model, separate neural network. Let's say you're building separate, let's say support vector machine. Just as you have building 3 independent models, we can build 3 different flavors of neural network. And for this, you can set 3 different samples can be allocated for this. Okay, guys, you can see here, this is the, this is a very simple function. You can see here, neural net is a function that I'll be using. This here, neural net function, open bracket, dependent variable, till plus GPA plus mac. Right? Instead of this admit variable, if you have response, campaign response, what will you give? Whatever variable is the dependent, we just specify here, put a tilde symbol, and then sum of all the independent variables. Is this clear, Pamela? Pamela? Is very clear? Right? Right? Whatever dependent variable you want. When I say whatever, provided it is category.
I think we need to do the attach before that.
Right? Dependent variable, tilde sum of independent variables. Data that is used to train is basically training. Hidden layer, when I say 1, what does it mean, guys? Single neuron. I'll be just using a single neuron to begin with. Right? Just very, very simple vanilla model. Later we can just complicate, we can mess it up, right? To just make you understand. And the error function here is basically cross entropy. This is the error function that we will be using. Right? Linear dot output equals false. So what I would suggest is basically, okay, you can just run this since this is a very vanilla model. Okay, so I will just be collecting I'll just be recording all these things. Hidden layer. This is the first hidden layer, correct? And with a single neuron. This is my trial one. Okay. Now that we have done this, the next step is basically to plot the N. The next step is basically to plot them. Are you able to see this? Right? DRE, GPA, right? Right. These are the three independent variables. You have pushed it into the input layer, and whatever is there on top of the arrow is nothing but the weight that it has. Are you able to understand? Minus 0.64, minus 1.05, 0.68. These are nothing but the weights. And whatever you see at the in blue color is basically the bias. There's a bias here, and again there is one more weight that it is this is the output value that is going. There's one more bias here, and in 10,568 steps or iterations, it has converged and it is giving you the error at 161.1. It can't reduce the error beyond this. Right? It has gone from 10,568. I think 1 lakh iterations. So default R can. Are you able to get this? Pretty fast on a small data set. Large data set, if you do, it will, right? Are you able to get this so far? Now, this is important, and I'll just sort of minimize this so that I can just sort of take you through the calculations. Okay, so with this is neural network. Let us just predict what is going on. Okay. Let's just predict this, please. I'm going to use the compute function. I'm going to use the compute function. N is nothing but your neural network model. Put a comma, training minus 1. You'll be generating the predictions for the training data set. Right? Minus 1 means the dependent variable will be dropped. When I say minus 1, the dependent variable will be dropped. Ganesh, your problem?
This one is lost now. It's training minus 1. If the leaf of we need to drop and mid.
What is the first variable that you have? First variable. Python is 0 is index. Yeah, first thing, 1 variable. First, in Python is 0, 1, 2, 3. Here it starts with 1.
So then we have better than minus.
First one. First column is what I'm dropping. If you want us to be more sure, let us just see for. No, let her. Otherwise, she'll feel. View. You can just see here. First column is that. Yeah, that's what it will drop. Because R is 1 base index. Right. First row, second, 2, 1, 2, 3, 4. If you're doing in Python, 0, 1, 2, 3. You use too much of Python. Huh?
Yeah.
I mean, it happens. Okay, so far clear, Rabi? Can I scroll up? Further up? Ravi, shall I copy the code and send it to you?
Yeah, I've taken this screenshot.
No, I'll just copy this and put this in the chat so that it's a lot easier for you. You can catch up with us. Okay. Guys, this is how I've generated the output. The next thing that we have to do here is basically, let's just examine this for one record, whether it is doing the right thing. Okay. So I'm just saying head output dollar net dot result. Correct. So you can see here, when I say head of output dollar net dot result, right? So this is my output where I'm generating the predictions, and it is generating the prediction. The predicted probability of student admission, whatever it is, here it is 18%. So the second one is 7%, and the third one is 34%, as predicted by the neural network model. As predicted by the neural network model. 18%, 7%, 34, 33, 69. Clear?
Can we see what?
So we have trained the model using training data and then again computing the training data.
Yes, yes. As of
So now we've completed the training.
Yes.
Can we see what is there? now?
yes. Just say output. Just say output. It may print a lot of things. For everything, it is just giving the output here. It's just generating the predictions. That's nothing else. Okay. Yes. Okay. Shall we make a more? Okay. Guys, let's just take a look at this, please. Head of the first record. Let's just examine the first record, please. Let us look at the first one. If you look at for one person, right? See, he has a certain GRA score, GPA score, and rank certain values for independent variable, and he is actually predicted as 1. He is being admitted. But if you look at the predictions generated by our model, it is saying that there is only 18% chance that he will be admitted, and therefore he is not admitted. So this is the first, our first case itself is misclassified. 18% is low, therefore obviously he'll be put as 0, not as 1. Second person is basically 7%, even lesser. So this fellow also will be called as what? 0. 0, but I have not seen what is the actual category, right? We can see that if you want. Okay. First person itself is a misclassification here, right? Okay, let us just try to, get inside this. Let us try to get inside the mind of neural network and understand what it is trying to do, right? Let us please step into the mind of neural network. Now I explain. All right. Load output calculation with sigmoid activation function. Guys, can you see this? This is the first neuron, second neuron, and the third neuron, right? First, second, third, and this is the fourth one, and this is the fifth one. 5 neurons, very simple, correct? So ideally speaking, if we are getting 17%, I think we got the first person. How should we? How is it doing it? GRE multiplied by this plus GPA multiplied by this plus rank multiplied by this, right? Will generate a score for it. Right? weights multiplied by the individual variables. When I do the weights multiplied by the individual variables, please check if the weights are correct here, or else you can correct me if I'm wrong. Wait. You have to, yeah, it will be different only. For every individual, the weights may be different. So here, in my case, what is the weight here? Minus 0.6. So this is the wrong thing which I'm using, correct? If you look at the first person, what are his characteristics? So this is 0.75. This number has to be changed. What is that? My GRE score is minus 0.64, correct? So let me just do a minus 0.64. And for GPA, it is negative 0.105. Negative point, negative point, negative 1.05, sorry, negative, what am I doing? 1.05 times 0.81, that is your GPA score. Then 0.68 times rank. 0.68 times rank value. 0.68. 0.68. I'm just taking the sum product of the weights and the individual variable, correct? And I'm storing this as right, a value, and this value will be used as the input for node 4. IN4 when I take the sum product for the first person, it is minus 0.837546. This is the bias term. You're absolutely right here. In my case, the bias term is minus 0.896. So this also has to be changed. Minus 0.8, sorry, minus 0.8 963. Bias plus, I think, minus 0.64 times GRE minus 0.105 times GPA plus 0.68 times this value. I hope this is correct. Okay, you may have some rounding of error because I'm not using the exact value. So I'm just using the first 2 digits. So this is in the input. This will serve as the input for node 4. This is the first node. Please see this. Node 1, node 2, node 3, and this is my node 4. Right now, at the second stage, what am I doing? What I'm doing is basically passing this through the activation function. Correct? Since this is a sigmoid activation function, I'll have to use 1 divided by 1 plus exponential of minus input for 4. Sorry. You can copy your system.
Yeah.
Sure. You want me to dictate something?
So the node that nothing but GRE, GPA, rank, and we're taking the first value, right?
Yes. For the first, if it works for the first, the same principle is applicable. I'm just comparing.
So we should get that weight value, right? Finally, 2.3.
What? How did we get 2.3?
So weights multiplied by the input
Yes.
plus by us. We should get the value of the 2.3. At least it is 2.3, but I'm getting negative.
Wait, we have one more layer, right?
So this question.
It's not value. Correct. Minus 2.5. Some product will be 3.3. That's correct.
Where are you asking for the activation function? The activation function itself is missing now. So you're taking the sum product of the weights and the variable, storing it as input for 4.
Activation.
This is the input for the node 4. This input now you have to pass it through the activation function to get the output for 4. What will come inside output? What will come inside node 4 and what will go outside node 4? This guy in 4, can you see here? On this guy will be fed inside node 4. When it comes out of node 4, you will get output. Are you to understand? Why negative? 1 divided by 1 plus exponential of negative this. That's it.
Negative.
Correct. What happened, Tejas? Tell me. I may not get the exact answer, but I'm just telling you how it thinks. That's it. Okay. Simple steps so that we can just mimic the thinking of neural network. Yes, this one, no? 1, 2, 3, 4, 5, 6, 7, 8, 9 sixes.
Hello, Mithun, can you hear me? Hello.
Show me the picture. So this is your weight, 0.82, 0.35, minus 0.87, 0.82, 0.82, 1.35, and you have negative 0.87, correct?
Yeah.
These are the weights.
Hello, Mithun, can you hear me?
Now the characteristic.
Hello.
0.75.
Hello.
GRE in your case. First variable is GRE. CPA is 0.85. This is also correct. You take an exact value better than
Hello.
this is 0.6.
I can hear you, but I think Sar is on mute.
That input will be passing into the activation function. Get the output value.
You can hear me, right?
Yeah, I can hear you.
Yeah,
think Sar kept on
was
mute.
saying that, no, I don't know, because I was asking, he said that, he was unable to hear me. Yeah. Prajwal,
Yeah, I can hear you.
Prajwal, we also need an online support, yeah, bit.
Yeah, I can hear you because I'm attending online. I don't think from the lab they can hear you. I'll ask them to contact you in 1 minute. Okay.
No, at least, ask them to just check on us as well, because we are also having some doubts. But I'm trying to ask him since morning, but I don't know. Maybe
So far
that's
is
the
clear.
reason.
Correct. Some product.
Hello, Mithun, can you hear me?
Pass it through the activation
No.
function. That is the output. Right. Please do this. You will be able to understand how neural network works. Right. Rather than just using it as a black box. For one case, we can just study, and for the rest of the things, it will work as fine. Parashuram, can you please be louder because I'm not able to hear a word that you're saying.
Yeah. Yeah, but I'm speaking very loudly as well, because
Okay,
the entire all people are also hearing. So Mithun, my one request is that we could not able to make it to the campus. Please also ask us that whether we completed or not, because we have some doubts here.
Sure,
So however, yeah,
yes.
however, from the graph, I do understand that the first node, second node, third nodes. And can you just again explain me this 0.8963? How did you get it? And also, I did not see that any formula reference something you told us.
Are you able to see my screen?
Yeah, I can see that.
Okay, so here, are you able to see this picture, please?
Yeah.
Are you able to see this picture? So what we are doing is basically these, whatever numbers are there on top of the arrow are the weights. So minus 0.64 is the weight of the variable GRE. Minus 1.05 is the weight of the second variable GPA.
GPA.
0.68 is the weight of the variable rank.
Yeah.
So far it is clear. In your system, you'll get different numbers because
Yes,
each
I got
of
the
our
different.
neural
Yes.
network weights will be different, right?
Yes.
So I am pulling out, I'm just showing in my system minus 0.64 times GRE plus of minus 0.105 times GPA plus 0.68 times rank plus of this bias term, which is shown in blue, which is negative 0.89, will be the input for node 4. This is my node 4. Is this point clear?
No. I confused because initially you did not take minus 0.8963. What is it?
So this is what, can you see my screen?
Yeah.
Minus 0.8963. This is what I've taken, bias term.
From where it taken?
This one, you can see here, this is the bias term.
Okay.
I am
Okay,
putting a plus sign. I'm opening parenthesis here. Minus 0.64 times GRE. Minus 0.64 is the weight. What is the GRE value for the first guy? If you see here, the GRE value for the first guy is 0.7586207, which is what I've written here.
Yeah.
I put a plus sign here, and then I am pulling out the weight for the second person minus 1.05 multiplied by the coefficient of GPA, which is 0.81, which is what I have written here. Is this clear?
Thank you. Yes, now clear. Can you give me a minute? I will prepare the
0.68
code.
multiplied by rank. The rank value is 0.666. This is what I'm doing, and I'm saving this as an object input for fourth node. First node is this, second node is this, third node is this. When you take the sum product and add the bias term, you will get the input value for the fourth node, which I am sort of highlighting in the mouse. Now this input value should be passed through an activation function. Therefore, I'm saying 1 divided by 1 plus exponential of minus input for 4. So whatever value that you're getting for input 4 is minus 1.77 in my case, that I'm passing it through an activation function, and I will get the output from the node 4. So while the value minus 1.77 entered this particular circle, it did pass it through the activation function, and it spat out the value 0.14, which is the output for node 4. Is this clear?
Yes, Mithun. Yeah.
Yes. Okay. I was never able to hear your voice. I think I asked you many times.
Even in morning also I have raised this question. I do understand that I was able to follow you, so that's the reason I did not stress. But this was completely kind of strange for me. Give me a 2 minutes. I'll prepare this code.
Please take your time. Please take your time. I'm happy that you're speaking, because for the first time I asked everybody. I asked Zarar, everybody. Nobody would speak to me.
I did speak.
Okay, no
You
problem.
asked me, Parshuram or Zarar are there. I did speak actually.
No, that's okay. That's okay.
Not coming on the speaker.
But it's not that loud.
Okay, fine. No problem. You please do this. I'll just wait for you for a couple of minutes. So far, it's clear to everybody what is going in, right? To node 4, what we are doing, just sum product. And what is coming out is basically the value of the activation function. Tejaswini, is it clear? I'm just waiting for a couple of minutes, right? I don't know. I never heard him for the first time I'm hearing him. From morning also, I was not able to hear him. Were you able to hear? No, right? I don't know about Zarar. Zarar, are you able to follow? Okay.
One thing I noticed is if we have online and offline.
There's a huge difference. That's why I kept saying, right? I'm looking forward to meeting all of you.
And even the recordings are.
Yeah, I understand it.
So when we completely have online,
It's fine.
it's different.
Oh,
But
yeah.
you have both offline and
Mixed
offline.
is very bad, no?
Initially, we had only online. Those recordings are good.
Yeah.
Now
Mixed is because they're moving. I'm moving, right?
Yeah.
And I'm speaking. The voice quality will lag.
And the thing is, You will be more focused here to this.
Exactly, natural, right? Human, whatever I see.
Yeah, natural. It's quite natural.
And now let's say Vasudev is answering something, or I'm online, I'll not be able to hear what it is. Even if the recording is too much.
It gets disconnected, like, okay, now.
The first day of any module is very important. First day of any module, if you lose that,
That's the base.
Difficult to catch up again.
Greek and Latin.
From here, it is better. We connect to the speaker, so if somebody speaks.
I have no problem. Somebody just needs somebody's help. Whatever connection you want, you give. No problem.
Can show it right little.
Absolutely. No problem.
There's no speaker cable here.
You can't connect it.
So. Not working.
Make it worse. Leave it, leave it, leave it. Parashuram, are you done? I'm just asking, by the way.
One minute. I just got int 4.
Sure, sure,
Give me to get output 4.
Sure, sure, sure. Please take your time.
Yes, Mithun, I completed.
Okay, great, fantastic. Okay.
Yeah.
I'll be making a move on now. Once we are through with this, the next thing is basically what are we going to feed to the node number 5? Correct? I hope this is clear. Node 1, node 2, node 3. This is node 4. What went in, what came out is clear to you. Now we are trying to understand what is happening in node 5. 1, 2, 3, 4, 5. What is the input for 5th node, right? Now here, I'll have to change this. I'll have to change this because this value is not -7. This will be -15. 15.69 it will be. In fact, it is this value, bias value 1.1757 plus the weightage is basically -15, correct? So that value I'll be typing here -15.6968.7. This is always the weight. The weight has to be multiplied with this neuron. What?
1.75.
Oh, yeah. Sorry. 1.7. 7 points. Okay, this is 8 to something, correct? Plus, this is the weightage that is given to the right output of 4. Correct? This will be the input for 5th node, correct? Can we run this? Parashuram, I hope you're following. Zarar, I have no clue how you're taking this.
Yeah, following.
Yeah,
Mithun.
great,
Now,
fantastic.
yeah.
Vinish.
Yes, Mithun, following.
Okay, great, fantastic. Okay, great. If you're following, great. If you're silent, I'm assuming that everything is going on well, right? If you're silent, I'm assuming that everything is fine. If you have a concern, please call up Sai.
Yes.
Okay, he can
Yes,
just
yes.
pass on the message.
Sure.
Input for 5. Is this clear, Pavna? Vasu? It's okay, we'll see. We'll have to again pass it through activation function, right? This is not the end of it. You see, some product at the bias term, you will get the value. Pass it to the activation function, you will get a value between 0 and 1. That will be the input. Calculate the weight, multiply it, add the bias term, get some value. Again, pass it to the activation function, your final value will come. It's just an intermediate step that you have done. Okay, input for 5, correct? Correct. Now shall I take this input, right? What is, this is my node 5, correct? 1, 2, 3, 4, 5. What is going inside this is this value of input 5, correct? Let me just display it for you. Let me display the input value of 5. Why is nothing coming out? Input 5. Negative 1.50. Can you see here? Negative 0.50 is going inside this particular node, right? And then we are going to pass it through the activation function, sigmoid activation function, and we are going to collect the value as output from the 5th node, right? Now, what is the value of the output in the 5th node? 0.37. Is this not the predicted value that we obtained earlier for the first person? Is this not the predicted value? 0.37. If you want, let me just run the compute function once again. Head, yes, right. For the first person, I think it is, sorry, I don't need to do this, just head. So 0.37 something, there could be rounding off error. So for like this, for each and every value, it is calculated. Clear? Some product bias term. That will be the input for a particular node. Adrinda output baratte, pass it through the activation function, one value sigatte. Adik puna weight, arrow mail that's the weight value. Puna multiply madi, you will get some value. Pass that value to the activation function and final answer. Is it clear? Neural network, is it clear? Bhavna? Understood how is it computing the weights and such things, and right? So yeah. Now shall we make a move to the next step?
Hello,
The next. Yes, please. Yes, Parashram.
Yeah, so you were just explained that when we have used the second time of the output 5, that is that value is equivalent to the first value of the output. Is that right?
Can you be a bit louder? I'm not able to hear anything. Can you please be louder? Sorry to ask to say this again.
No, it's okay. I'm just preparing myself with throat.
Sorry.
So yeah. So when you said that output 5 value is matching with the second of the output, right? Because it is the second value of the second row value.
Yes,
is that right?
Yes. So there's a 37% chance that this guy will not be admitted.
Not make admission. Yeah.
Yes.
So what about output 4? The output 4 is not listed. Is
output 4
just to get the node?
Output 4 is the value that you are getting at the hidden layer, right? What is happening in the hidden layer is just an intermediate step. We are looking at the final value that we are going to collect at the final output node.
Okay.
Not at the stage of hidden layer.
Okay.
So output 4, if you see here, first node, look at the cursor, first node, second, third, and fourth. This is just a hidden layer. We are not collecting anything. We are not interested in anything that is going on here. We are interested in the 5th node because this is the final node. This is the final output that I will be getting. And that is the predicted score of whether or not a person will be admitted, or tomorrow, whether or not a person will respond to a campaign or not.
Okay. Yeah.
Okay. Clear?
Yes, thanks.
For one person, it is holding good. It means that for all the persons, it should hold good. Now, what will we do? We will generate the confusion matrix for the training data set. Let me just generate the. I got the exactly the output. Yes, a good sign here. I got the same output. Yes, so you're getting 0.37. Yes. So my output is matching with that. So it is based on the different. Different weights. Yes. Okay. Now, as you can see here, let's please generate the confusion matrix quickly. Let's please generate the confusion matrix. Again, I'm going to run the compute function, right, by dropping the first variable. P1, let me please run, let me collect P1, which is nothing but the predicted score, correct? We will be specifying a simple if condition. Look at this simple if condition. If the P1 value is greater than 0.5, we will call him as 1 or admitted, else we'll just be calling as 0. Is this clear? And we'll save this as predicted 1, pred 1. Yeah, that's okay then. If you've already run it, no need of running it again. Right? Now the table function, I'll be comparing the actual versus the predicted. So tab 1 is nothing but table of this. Correct? So let me just show you the output of this. Are you able to get this confusion matrix? Are you able to get this? Are you able to get this, guys, everybody? Okay, I'll just give you some time. Take a couple of minutes, please. Take a couple of minutes. Are you following? Silence. We can run this on the test data. I'll be doing this after this. First, I'll run this on the train data itself, right? Just to see if there's any overfitting and systems. Okay. Guys, are you all getting this? Numbers may not exactly match, but that's okay. Just understand the concept. If you're clear with this, I'll just talk about one more important concept, which I feel you should know, right? And it's absolutely necessary that you understand this concept. Perhaps you already know this. Okay. Is this can? Parashram, are you ready or do you need some time?
Mithun, I'm done. I messaged you in the chat.
Okay, okay, fine. Bhavna, you're getting it? Hi. You both are getting it? Tejaswini, Pranesh? That's okay, because we are getting different weights.
Hello, Mithun, can you hear me? Hello?
Yes, please.
Yeah, the predict and one you have used if else function, right?
Yes.
So just wanted to ensure that my understanding is right. This is the condition, P1 should be greater than 0.5. If the condition is true, label it as 1. If it is false, then it should be 0. Correct?
You're absolutely correct.
Yeah.
You're absolutely correct. Yeah.
Okay.
Okay, guys. If all of you are on the same page, shall I just show you something, guys? Maybe you already know this, but I just want to still reiterate this point. Correct. I just need a bit of your help here. Let me just use a different sheet here. Can you just tell me the values in the? Yes. Right. What is the? This is 0, and here we have a 1, and here again we have 0, and we have 1. Yes. Yeah. I'll shift. Control X. Can. Okay, now. Okay. Can you just tell me some of these numbers, please? Okay, 172 here. 66. This one would be
17.
70 here.
17.
26. 20.
6.
Okay, So what you have along the row is what is called as actuals, and what you have along the column is basically the predicted. Very clear with this? Now from this, right, there are four numbers that you can see, correct? Now these four numbers, we have to give a proper meaningful label here, correct? See, when the actual is 0 and the predicted is also 0, you can call it as true negative. Are you able to understand? So this value of true negative will be how much? 172. So this I'll be coloring in blue, indicating that it is correct, or maybe green I'll cover, I'll sort of color. Then when the actual is 1 and the predicted is also 1, that is true positive. So this is 26. Correct? Then when the actual is 0, but the predicted is 1. What is this? False positive, and this is 66. And finally, you have the false negative, which is 17. What is the overall sample size here? Right? If I just take the sum of all the values, I will be getting 281. Right? Now from this, the diagonal elements always represent the correct classification. The diagonal elements always represent the correct classification. So if I want to calculate the final accuracy, all that I need to do is take the sum of the diagonal elements like this, right? Put this in the numerator and then basically divide it by the overall sample size. So this neural network that we have built with one hidden layer is giving me an accuracy of 70%. Correct? But do you see any problems with this? Do you see any challenge with this? We are getting the accuracy, but what is the main problem with this? Imbalance is one thing, but even otherwise, just why F1 score?
Accuracy will be always high because the data points for 0 plus 8.
Exactly, right? So here, let me just give you an example, guys. Let's say you have ID and you have 10 people. Right? Please look at this, guys. Everybody, please look at this. Right? Let us say the actual class of a person. I'm just taking a random one, and let's say 1. Right? Let's say this is the actual class, and forget a model. Right? Let us say I'm just giving this to Sai. Right? I'm just giving an example of Sai. Let's say when I give this to an individual, he says basically he does not understand what is this nonlinear curve, what is linear curve. He does not need. He will say everything I'm going to call as 1. I don't need a model, no linear, no non-linear, no decision tree, nothing, right? You give this to a child, everything I'm going to classify this as 1. Now here, if you see, it is still getting right, correct? 1 versus 1. Here you can see there are some ones which are being correctly classified. In fact, all of the ones are being correctly classified. Why should I not use this? Fifth one is this. This is also correct classification. So out of 4 positive cases, my model has got 4 of them right. Without any model, just random guessing, I'll put everybody as 1. You'll still be able to get things right. Correct? Then why do I need a model at all? If you look at the actual accuracy of our model, it is only 70%. But here you may actually get more accuracy than you building a model. Then why do I need a model? This is one question.
So it depends on the type of data. In that case, we should be focused rather than accuracy will always be 99%. But what we are trying to predict is it a span? Maybe the number of images would be less. So that it's like identifying the true positives.
So here, one point that you all need to keep in mind is, right, this may be an accurate model, but it is not really a precise model. From the point of view of statistics, an accurate model need not necessarily be a precise model. Some models are highly accurate, but imprecise. Other models are precise, but less accurate. So we need to look at another metric here, which is called as precision metric. Right? This is all data science language that I'm using now. We need to look at precision metric. Now, firstly, I can confuse you by writing a formula there, right? One is we can just write a formula. But I'll anyway write the formula so that it is very easy for you to follow. TP divided by TP plus FP. Correct? So this is how we will be calculating the precision TP divided by, which is true positives is divided by the sum of true positives plus false positives. Correct? So when you say TP, where true positives, correct? So let me just copy the same thing here. Correct? And call this as true negative. This will be my true positive. And this number 66 will be my, tell me, this is my false positive and this is my false negative. So far you're clear? I'm just labeling it next to each other so it's very easy for you to follow. Now when I say TP divided by TP plus FP, what am I looking at? All right, so this is TP. This guy is TP, TP plus FP. What is it that I'm looking at? So 66 plus, right? Yeah. So how can I interpret this? How can I interpret the precisions? How precise is my model? So for example, can I put it like this? Just focus on this number 93 because this is the sum total of these three things. Correct. Out of the total predicted positives, I'm using the words very carefully. Out of the total predicted positives by the neural network model, how many has it got it right? It has said that 93 people are positive, but in reality, 26 of them are right. So what we are trying to do is basically take a ratio between 96 and 26 and 93, which means that my neural network model is precise only to the extent of 28%. Out of every 100 individuals that the neural network model is predicting as positive, predicting within double quotes, predicting is right. Only 28 of them are truly positive. Are you able to get this point? Right now, one clue that I can give. I don't know if you're already sort of comfortable with remembering this formula. P here, precision starts from P, the letter P, correct? In the numerator also TP you have, which is positives. Denominator you have P and P. Right? Everywhere you have P here, right? TP divided by TP plus FP. Now the second one is basically recall. This is also very important. What is this? It is the same thing as about TP divided by TP. Tell me. FM. Right? Now, how do I interpret this? So here I looked at the column total. Am I right? Here I looked at the column total. This is the column total I'm referring to. Let me just highlight in red for you. Right here, I will be looking at the row total. Correct? Equals sum of these two numbers. Correct? When I take the sum of 17 and 26, is this not TP plus FN? The denominator is my denominator is ready now, which is 43 here, correct? Which I will highlight using a different color. Let's say I'll color it using yellow. This is 43 here, correct? So what am I trying to do here? Where is my true positive? It is continuing to be 26. I'll be taking 26, dividing it by 43 here. So when it comes to the recall, it is 60% accurate, which means what? Please understand what is the meaning of 43. This is the actual number of positives. Out of 43 people who are actually positive, my neural network model has got 26 of them rightly as positive. So recall is basically out of the actual positives, how many of these cases has your model got right? And your precision is basically out of the total predictions made by the model, how many times has the model got right? Is this clear to you? Right? Precision is out of the total predicted positive. That will be in the denominator. Out of the total number of people that your model is saying has responded, how many of them have actually responded? So prediction is given emphasis there. In the case of recall, actuals are basically given emphasis there. Are you clear with this? Now, these are the two metrics that you can look at. Now, over and above this, you can also look at F1 score, which is simply a what? It is simply a harmonic mean between precision and recall, right? It is simply a harmonic mean between the precision and recall. So I'm just taking the product in the numerator, and in the denominator, I can just take the sum of these two guys. No. This is wrong. OK. So this is your 38%. Correct. So you can just take a look at the difference between 70% and these numbers, which is how bad your neural network model is. Right, 70% is really falsely deceptive. Now, one obvious question is basically when do I use the precision, when do I use the recall, and when do I use my F1 score? Can you see here in the denominator what do I have? I have false positive. Right? If false positive is an issue in your business and you want to penalize a model, you want to punish the model for false positive cases, then basically you use precision. FP is in the denominator. Do you agree? When is this FP? It is in the denominator, right? So since FP is in the denominator, if false positives basically increase, precision comes down. The new overall quantity goes down. On the other hand, if FP is lesser and lesser, precision will go up. So in those situations wherein false positives, wherein the cost of false positive is very, very, very high, use precision. In those situations wherein the cost of false negative is very, very high, use recall. Let me give you an example. Let us say there are patients, some of them have tumor. Some of them have tumor, right? But when they come for diagnosis, the instrument or the device basically, though he is suffering from tumor, my model is saying that he is healthy. He is tumorous. My model is saying that he is healthy, which is basically a case of false negative. Negative is a case basically is healthy. It depends upon me what I call as negative and positive. So this is a case where it is false negative. What is the cost of this? Because my model has set that he is completely healthy, he will go untreated. He will not get any medication at all. And in 3 or 4 days, there's a good chance that he dies. So the cost of false negative In pharmaceutical companies, healthcare and such areas is very, very high. And therefore, in mostly healthcare, pharmaceutical sector, you pay attention to recall. On the other hand, if you're talking about fraud detection and such things, right? A person is a fraud. Fraud, let's call him as a positive case, right? Right? Or let me just give you a different example. Let's say a mobile phone, correct? Every day, basically, let's say hundreds of mobile phones are basically getting manufactured, right? The lot inspector goes and he randomly takes a few mobile phones and he examines it. Maybe he's untrained, maybe he's basically a new guy. He does not know how to basically evaluate, right? There's a lot of confusion in his mind, right? So he basically says that this is what? Falsely positive, which means it's a good product, but he says that there are certain defectives, there are certain problems with the mobile phone. And because he says it, let us say we don't take it to the next level, it does not see daylight. Right? So if even 15 such mobile phones do not reach the consumer's hand, 15 into cost of each mobile phone, that is the loss that you are suffering. So in manufacturing sector and such things, you might want to consider false positives as a serious case, and therefore you'll be looking at where you have a genuine class imbalance issue. It is better to look at F1. Are we clear with this? Accuracy, F1 score, precision, and recall. Right? F1 score is a derived metric, so you don't always need to look at this because it has the properties of both precision and recall. Just ask a simple question. For my business, is false positive more costly? Is it more harmful? Or is false negative more harmful? If you say false negative is harmful, you know which is the formula that you need to apply. On the other hand, if you say false positive is more harmful for my business, you know which is the formula to be applied. Healthcare, pharma, usually they go by what? Recall. And for manufacturing and such things, usually your precision and such things is preferred over accuracy. Should we quickly break for tea and come back? Parshuram, I don't know if this is clear to you.
Yeah, my question is that I did not hear last word properly. So the fraud detection and manufacturing, they go for precision, right?
The case
False.
of
Yeah.
In the case of healthcare, pharmaceutical companies, and
Recall.
your drug manufacturing and such things, you can go for recall.
Yeah.
In manufacturing sector and such things, you can look at precision.
Okay. Yeah. Precision. Thank you.
Okay.
Sure. Thanks.
Okay. Is it clear?
Yeah.
For coffee and come back. Decorated scooter. It is very. So you are using this one, lines, orange ones.
Random forest. Random forest. ಒಂದೇ ಕ್ಲಾಸ್ ಇಲ್ಲಿ ನೋಡಿ ಇಲ್ಲಿ